Hi, this is Nolan Rudolph, and this video is made to demonstrate the purposes and usage of my GitHub project multi-dimensional monitor that can be found under this URL. Now we'll begin by instantiating a profile on Cloud Labs that I've made specific to the needs and requirements of my project. Go ahead and click Next. This node type will suffice, but if you want to know what this node entails or alternative nodes that you may use for this project, they can be found under 11.2 Cloud Lab Wisconsin at this URL. We can go ahead and call this example, select the Wisconsin cluster, Clemson cluster. The topology looks okay for our project, so we hit Next and Finish. Now, this portion, the setting up of the project, can take upwards of 10 minutes. Therefore, I will see you back when this process completes. Okay, so we have finished our setup here, and what I've done is gone ahead and created 3 different workspaces: terminal with client, terminal with server. The next workspace has replica 1 and replica 2. And the third workspace has replica 3 and replica 4. Now how I did this is you will have the topology view down here, and this will be all mixed up, but I have designed it to look analogous to this model here. And what you can do is, in a new terminal, you can go to list view, grab one of these secure shell logins and do something like that, and boom, you're inside the server, and instantly sudo bash, which is bad practice, but it doesn't matter because these are remote nodes and they can easily reset. Okay, anyways, we don't need that, that's already down here. And once we have all of those, I've gone ahead and taken the liberty of grabbing the MAC addresses and the IP addresses. Now this will most definitely differ from person to person. The IPs will remain the same due to the instantiation of the Cloud Lab profile. However, the source MAC address is subject to change, not throughout the course of the project, but just from person to person who's trying this out. And that can be retrieved easily by going to your ifconfig and grabbing the Ethernet address that coordinates with your VLAN. Now there's 2 different VLANs because we're linking Clemson with Wisconsin, and we can see that in our Wisconsin plane or workspace it remains the same. However, in our Clemson plane we have a different flag, which is okay. I've already configured my project to accommodate for that. So now that we have all of these, we can continue with our project. The first thing you're going to want to do is clone this repository and the snap repository. I've already gone ahead and done that on all of these nodes, and this is what it should look like from your home directory. Okay, next we change directory to a multi-dimensional monitor, and there will be a setup.sh in there. And we can run bash setup.sh to run the script that auto setup. Now, according to this comment, we should not do this with Debian, and I've gone ahead and included a detour if you do not have Debian machine. Okay, now next we can just run this command, and this will set up our snab things, which include the client, server, and replica, but it's an important next step to configuring our project. And our last one is just simply for the user to start experimenting with what is available with respect to the Snab API. And we see here we're allowed 3 different options, and we can get extra information by adding which one we want and help. Okay, I think this is a good place to leave off here. I'm going to continue on the next video. Okay, we are now onto the final step of configuration, which is not listed in setup. I need to do that after this video. But what we will be doing is editing the YAML file, which is found here in Cassandra, which Cassandra was installed here via the setup.sh file in my repository. So the thing we need to do on every single node is replace the RPC address with the IP address of the node and the interface with the interface of the node. So I've already done this on all of my nodes, but a good way of looking for this is doing a string search for VLAN, changing that respectively. I believe it starts at 914, and just change that. And then you can also do a string lookup for 192.168.1.1. If you press next 1 or 2 times, you get to the RPC address, which should mimic the IP of your node with respect to the VLAN. And as you can see, I've also gone ahead and done that down here. So Cassandra.yaml. These two nodes share the same interface, so this should also be 921. The replica 1 node has a RPC address or local, or the address that associates itself with other things on the same link as 192.168.1.2, this being 1.3, and we know all of this from our little document here. And lastly, the Cassandra nodes, or not Cassandra nodes, the Clemson nodes are going to be a little different. Since they're in Clemson, they're going to have a different interface, which links everything together. And we also want to be, once again, mindful of the differing IP. So we go back to Cassandra.yaml. We go ahead and look for VLAN. You can see I've already changed it to 2228, and I've already put in the RPC address as well, and I did that with replica 4 as well. So that's all we need to do to make sure everything is talking with one another and that our configuration is entirely finished. And the one last thing we need to do is do service Cassandra restart, so that the Apache Cassandra services can begin to utilize Gossip Protocol to find other nodes that have been specified by seeds. And we can see here that these are the ones we want to communicate with, and the client node's just in there because I think I need to remove that. Okay, and that's the end of the configuration. So let's go ahead and make sure that everything is set up correctly. Going to our client and server workspace, we can do what I have just done up here, which is service Cassandra status, and we will get active running. If it said active exited, then you're gonna go ahead and what I do is I cat log Cassandra, and then I believe it's debug.log, and you can find it in here, and it will say something like error, blah blah blah. And that's a good way of debugging the problem with that one. Next, you're going to want to go ahead and type in node tool status. And we should find all of our different nodes. We have .1, .2, .3, .4, .5, aka server, replica 1, replica 2, replica 3, replica 4. And this is great. So that means that they're all talking with one another, and I will show you that this is what's happening through one of the testing things I have created. So here we have 3 different modules that help us communicate with the rest of the database: make.py, synctest.py, and recKey.py. Make.py is responsible for actually putting new entries into our database. Sync test allows us to see if those were actually replicated in the other databases in the replica nodes. And rec key is used in conjunction with the Snab API to actually get the value pair and return it back to client. So if we go ahead and go into our make.py, it's already begun by creating a key space and a table right here, and there's a key space. And now we can go ahead and maybe add 3 key value pairs. So we can go ahead and call this CIS, and maybe you're taking 471, or your name is Nolan and your last name happens to be Rudolph. And we have to go with the classic hello world. And we can go ahead and do python make.py. Okay, cool. So how do we know that even works? Well, we've only been talking to our server node. Let's see if those changes were replicated in replica 3. So that's when sync test comes in handy, because what we can do is we do python sync test. We can give it the IP address of ourself. And just to show you that this is our IP address, I'll go in really quick and show 192.168.1.4. I just have these all memorized by now because I've been tinkering with this for quite a while. And look at that, it is perfectly synchronized, and we can do the same thing over here. This is 1.5. Whoops. And what's cool is that my sync test also allows you to test different IP addresses. So this is, we just asked replica 2 if it had a synchronized database. So that all looks fine and dandy. And we are finally done with our setup. Everything is working together using the Gossip protocol initiated by Apache Cassandra. We have synchronized databases. And now we get into how do we utilize these different Snab features. Okay, we have finished configuration and we finally get into the more exciting side of things. So we see here we have help commands for our client, our server, and the replica. So as we're going to replicate or configure the server first, so maybe we're not done with configuration yet, but we're almost there. So here we go. We need a interface, source MAC, client MAC, and a file containing destination MAC address. So we can begin with our interface, which is VLAN 921. Then we need to give it our source MAC address, which is our server. We need to give it the client MAC address, which is this guy. And then lastly, we need a file containing the destinations. Now, I've gone ahead and created this, and it's really simple to create. All you have to do is specify how many nodes it's going to test the latency between, followed by the 4 entries. And here we can see that I've just gone ahead and put them all in succession with one another. So we have replica 1, 2, 3, 4. Okay. So we're almost there. We just have to finally put desk.text and give it one more second. All of the nodes are offline. And this is correct because we have no replica nodes listening in for that latency test to respond back to the server. So let's go ahead and configure one of those nodes. We put it in and we see we need source, MAC, dest, MAC, interface name, and the disk type, solid state drive or hard disk drive. So we'll go ahead and go back to our address sheet, and we'll go ahead and grab, so this was poor documentation. The source should be where is the packet coming from, and I'll make sure to specify that later. Where is it coming from though? It is coming from the server. Where is it coming to? The destination is us, the replica 1. The interface, it is a simple ifconfig lookup, but I've already memorized the interface, and we will give it a solid state drive. Now this is just to show that we can add extra parameters to how the latency is affected, and this is all simulated. It's hard coded in as a set number of milliseconds for solid state drive versus hard disk drive, but it just allows us to see that we can actually affect how it responds. So we go ahead and we go back up to our server and we see, oh, replica 1's online and it's responding. You can see right here it's responding. Now we need to do that with the rest of them, and luckily I already messed up this video a few times, so we're giving this replica to a hard disk drive instead. We're going to come and so what's interesting is that the hard disk drive is obviously going to be worse, and this is an example of how we can affect the latency. It's obviously going to take longer to access memory in a hard disk drive, and the times reflect as such. And we're writing replica IP address 192.168.1.2 to file, and this is what this little thing right here is representative of. That's node file. And Apache Cassandra is going to be using that. So, okay. What's next? Well, I have already done this for the rest of the nodes, so we'll go ahead and do that. We give this solid state drive. Might as well give this guy a hard disk drive to kind of continue this. And we see they're all online now. Okay, great. And this will take us to the next video. Now we have just one last thing to do, and this is actually the meat of the project. No more configuration is needed apart from setting this up. So we're going to go down, and what does our client need to provide? Our client needs to provide an interface, source MAC, desk MAC, our server, and a key, what we're going to look up for. So we can go ahead and start inputting these values. We know that the interface is going to be blend921. The source is this. We can also reference our text document, but this is fine. The destination is going to be a server, and this we actually do want. Pull this up the page. And if we recall the different things we configured our database with, which was, that is make, we had CIS, Nolan, and hello as their keys, which should return 471, Rudolph world respectively. So let's go ahead and do hello world. Now we need our server to be up in order to do this, and we will begin the request. So we send a packet, got the request for hello, and it returns world. And this, that's it. It works. Cool, great. And I will change this to not run periodically. Once it gets the key, it'll finish. But if we look at the latency there as it warms up to the server, because Snap takes a little bit to get adjusted, it takes about 1 second. The return is so short, it's so fast, it's rapid, it sends a packet and it instantly receives it. So let's go ahead and try with the remainder of our values. We're taking that CIS course. What are we going to get back from the server? Nothing but 471. Lastly, oh geez, I need to fix that. The last thing is we put in Nolan, we should get Rudolph. And it's warming up to the server, and boom. And it sends, boom. And it sends, it comes back instantly. It's instantaneous. So that, that's a really good sign. And anyways, this is my project. That is really all you need to know. That is all the documentation videotized. And I hope you enjoyed. I hope it was nice and easy for you to configure, and stay tuned for new updates to this project.